All right, so we have multiple transformations that we learned last semester, and we kind of alluded to it when we were doing polynomials, but just to be very clear with what we're talking about, a parent function, which is square root of x, is what we started with in the warm-up. The parent function is like what you're starting with, the original, okay? And the transformations of functions that we talked about here is we're moving the locator point. So everything here stays the same, except we're shifting it up, down, left, or right. So this first equation, the first equation you guys saw was f of x outside minus 2. So basically this f of x is the square root of x, the square root of x with a minus 2 on the outside. If the minus 2 is on the outside, how is the function shifting in the graph? If we're subtracting 2 on the outside, is it going up, down, left, or right? It says going down. That's correct. When it's on the outside of the function, this is a downshift. It's a vertical and it goes down. Okay, so I'm going to redraw my graph. And now this is my g of x, root x minus 2 on the outside. What if it's plus 2 on the outside? It's not minus 2 anymore. What if it's plus 2? How is it shifting? It's moving up. It's an upshift. Okay, so if it's plus 2 on the outside, we're going to be shifting up by 2. Okay, and this is h of x equals root x plus 2 on the outside. Okay, now j of x is when I have f of x minus 3 on the inside of the parentheses. So I'm doing the square root of x minus 3 inside the square root. If we're subtracting inside the function, inside, how is it shifting? Left or right? Minus and the inside. We're shifting right. Even though it's subtract, when it's inside the function, it switches. So this is a right shift. And it's shifting by 3. So this is, it's j of x equals x minus 3 on the inside. And last but not least, we have k of x. The last one is a left shift. So it's going to look like 1, 2, 3, 4, 1, 2. It's going to look like this. And that's x plus 3 on the inside. All right, cool.